7.4. We talked about inverse functions. This is not a hard lesson. I think you're actually going to enjoy the break on this lesson, okay? We said in order to find the inverse of a function, we switch x with y. And that's how we do it. So if I start with y equals 2x minus 4, and I want to find the inverse of this, instead of y, I'm writing x. Instead of x, I'm writing y. And now I'm solving for y again, and that's going to be my inverse. What I really like to do is move my x on this other side and get rid of it from here. I need to add my 4. 2y equals x plus 4. I need to divide these 2 out. Y equals 1 over 2x plus 2. And this is my inverse. How do we find the inverse? We switch x and y and then solve for y. Not that difficult. Make sure you write this correctly. You could have just also written this as x divided by 2 plus 2. I would have not minded. However you want to write it is correct. But that's how we find our inverse. You switch your x with your y, okay? If you look at, we're on page 422, and you have that graph, and they say, please graph the inverse. You take all of those dots, you switch your x with your y, you replot them, and that's your inverse. Now, how do you determine that two functions given to you are inverses of each other? This is where the composition function comes in. If you do the two compositions, f of g of x and g of f of x, and they both end up with the answer equals x, then they are inverses of each other. So here's two functions that we have here. They want us to prove, and I'm actually going to do this as g of x, believe it or not, so it will not confuse you. What is f of g of x? And what is g of f of x? This is a composition from the previous chapter, right? And if I end up with both of them being x, that means the two functions are inverses of each other. So, f of g of x becomes f of 2, parenthesis, 1 over 2x plus 2. So instead of x, I'm now plugging that whole thing in, minus 4. Let's see what we get when we distribute. 2 times 1/2 gives me 1x. 2 times 2 plus 4 minus 4. That goes away. So my first answer is correct, is x. Now I need to prove that this one also is x. So this becomes 1 over 2, parenthesis. Instead of x, I am now putting in what I have here, my f of x. 2x minus 4, and then plus 2. Let's do the distribution. 1/2 times 2 gives me 1, that is 1x. 1/2 times negative 4 gives me minus 2, plus 2. They go away. I end up with x. The two functions over there are inverses of each other because the final answer is just a plain x. So when you do this type of work, just make sure you plug them correctly. Make sure you follow your signs correctly. If you end up with x and x, they are inverses of each other. If the answer is not that, then they're not inverses of each other. It's just as simple. Example 3 deals with calibrating a spring scale in order to know that you weigh stuff correctly, and they give you a model for one scale, which is L equals 0.5 W plus 3. L is the total length of the spring, and W is the weight in pounds of the object. And I say, first of all, find the inverse. We said in order to find the inverse, we put W equals 0.5 L plus 3. And now I'm resolving for L, right? This becomes equals W. 0.5 L equals W plus 3. I divide by 0.5, right? Now, 1 divided by 0.5 gives me 2, so this becomes 2 W's plus 6, and that is my inverse, right? That's where I am, that's what I have, and I found my inverse. The second question is, if my spring is 5.5, what is the weight of this melon that we put on the scale? Well, let's go ahead to this and go 5.5 equals 0.5 W plus 3. I put the 3 on the other side. By minusing, I get 2.5 equals 0.5 W. I divide by 0.5 in both places. That means my W is 5. The weight of that melon is 5 pounds. Now, the way they did the inverse, they literally just solved for W. Instead of just going through all of this, they just went, okay, if I want to find the inverse, I need to solve for that W. My weight equals L minus 3 divided by 0.5, or equals 2 L's plus 6, which is the same thing, except that we here officially switched them. Why would that be easier if you just go for the weight and solve for the weight and consider that the inverse? Because at this point, all I had to do is plug in here 2 times 2.5, and this is a minus 6, I'm sorry, not a plus 6. Yeah, this is a minus right here, guys, sorry. Okay, this is a minus 6, and this is a 5.5, sorry. But this is 11 minus 6, which gives me 5. But it's not worth it. We can just do the way, I don't want to confuse you this way, the way they did it in the book. I want to do the inverse the way we know how to do the inverse, which means we switch the variables and then we solve for whatever we started with. For the L, we get there. Once you get your L, you just plug it into your original function and you get your weight out. It's not a hard math to do. It's not that difficult to work with it. Now, in order to figure out if inverses of functions are also functions, we talked in class about the horizontal line test. Remember the vertical line test? We said that if we have a vertical line and I can't, oh, here it is, here's my rule. If I go through here and it only touches once, then it's a function. But if it touches more than once, my graph, then it's not a function. In order to find if that function has a real life function as its inverse, you're going to take the horizontal line. If it goes and it touches more than one place as a horizontal, then the inverse is not a function. If it only touches once and a horizontal, then the inverse is also a function. For example, we're going to look at this as find the inverse of this function. Well, this function is this graph, just really moved down. Really, x to the second looks like this. This is my x to the second. If I look at this and I put my horizontal line test through it, I'm going to say this does not have an inverse. However, because it's asking me to find the inverse, I want to first solve it and then see if I can make it a function. If I say y equals x squared, and then we switch it, x equals y squared, and I'm solving for y, I'm moving my x on the other side, take the square root, y becomes plus or minus square root of x. And if I just use my positive version of that, which is as a graph this, then this is a function, okay? Then this becomes a function. How do I find the function? I just keep the positive. If I move it to the negative, it's not a function anymore, okay? Example 5 is a little bit more interesting than this one. And when it says determine if a function given has its inverse as a function, I have 1 over 2 x to the third, I think it's minus 2. This is my f of x. And they're saying, can you determine if the inverse is a function or not, then find the inverse, okay? So if I would have to determine if it has the inverse, I'm going to go to y equals, I'm going to clear it out, I'm going to say 1 divided by 2 x to the third minus 2. Okay, I just put it on y equals, and I'm going to go zoom 6, and I'm going to graph it. There's my function. As I move my horizontal line, I notice that it only touches one at a time. It never touches my graph more than once at a time. I already know, yes, this one has its inverse is a function. I now need to find it. It's not that hard. Y equals 1 over 2 x to the third minus 2. You notice how it applies to f of x with y. I switch them. X equals 1 over 2 y to the third minus 2. I'm going to move my x on the other side. I have a problem with this. I'm the one that does that. I'm going to add my 2 and get rid of it. I'm going to times this by 2. Get rid of this. Y to the third equals 2x plus 4. I need to solve it. I'm going to take the root 3 out of it. Y equals root 3 of 2x plus 4. I did not use a plus or minus because my root is odd, so I don't have a plus or minus. This is the inverse, and I know it's a function because when I graphed the original one, my horizontal line worked great for me. Example 6, and the last thing on this little lesson is a word problem that gives us a formula that says the volume of the nebula of a planetary nebula is V equals 9.01 times 10 to the 26 all to the times t to the third, and t stands for time in age in years of the nebula. It says, first of all, write the inverse model that gives the age of the nebula in function of its volume. That means I'm really solving for t. They want me to tell them what t is, okay? So this becomes, I need to divide all of this. I'm going to move my v on the other side because I work this better. I'm going to divide all this by 9.01 times 10 to the 26, right? And I got rid of this once I did the division. And then I can take the third root in both places, and I end up with t equals third root of v over 9.01 times, I'm going to use a times like this, 10 to the 26. So this is basically the inverse, because the inverse is you switch the variables and then you switch for the other one. We're just going to solve for t to find my inverse. And believe it or not, I'm going to actually leave it right there. I'm not going to mess with it in any way, shape, or form. Now they gave us a v. They say the v is 1.5 times 10 to the 38. Solve for t. T equals 32. This becomes 1.5 times 10 to the 38. I'm going to use a dot. I'll divide by 9.01 times 10 to the 26. Cube root of, if I go 1.5 divide by 9.01, I get 0.1766. I'm just doing it like this. And then times, this is just 10 to the, this minus this is to the 12. I'm going to go ahead and put this in my calculator. I'm going to go math, option 4, right? Cube root of 0.17 times 10 to the 12th. Close my parenthesis, hit enter, and I end up with 5539 or 5540. They really just rounded up at about 5,500 years. We can just use the right answer, which is 5540, without any decimals, right? So really, in order to solve this problem, I had to solve for t. That's kind of how I found the inverse of it. And then all I had to do is plug my v in there and work step by step using a calculator and get my answer out. And this is all about your 7.4. I think it's an easier lesson. Happy homework.